So I want to have a look at graphing what's called the reciprocal function. So if we're given a function f of x, we might be given the function itself or we might be given its sketch. We want to be able to graph 1 over f of x. Now sometimes the notation for that is written as f of x all to the power of minus 1. Just be really careful that you're not writing it as f to the minus 1 of x because that means something entirely different. But we're looking today at graphing the reciprocal function. Things that we need to know. The three basics are that if we take the reciprocal of a very large number, we end up with a very small number. So if you did say 1 divided by 1,000,000, you're going to get something really tiny. And it works the opposite way as well. If we take the reciprocal of a very small number, we end up with a very large number. So if we did 1 divided by 0.000001, you're going to end up with a large number. And the last thing we need to remember is that the reciprocal of 0 is undefined because if we can't divide by 0, so if we take the reciprocal, we end up with 1 over 0, which doesn't work. There are a few things that we need to consider. We're going to read through these quickly and then have a look at what they actually mean in some examples. So if we have the graph of the original function and we want to draw its reciprocal, the new graph has the same sign for all values of x. So wherever it's above the x-axis on the original, it will still be above the x-axis on the reciprocal, and the same with the negatives. Wherever it was negative originally, the new one will be negative as well. The zeros of the original function correspond to the vertical asymptotes of our reciprocal function. If we have our function going off towards infinity or minus infinity as x goes to infinity or minus infinity, then in our reciprocal function, our x-axis is going to be a horizontal asymptote. So that might look like our original function might be like a cubic, for example, where x gets large, y gets large, or x gets large in the negative direction, y gets large in the negative direction. Then in our reciprocal, the x-axis will be a horizontal asymptote. When one curve intersects at 1 or minus 1, then the other one will as well, because if you divide 1 by 1 or minus 1, it'll just give you the same answer. When one curve is increasing, the other one is decreasing. And when one curve has a local maximum, the other has a local minimum. So that's when it comes to a peak. So it has a local maximum. The other one will have a local minimum. All right, so let's have a look at some examples. Example asks us to sketch y equals 1 over x minus 2. Now, when you're drawing axes, you should always use a ruler, but I haven't been able to on this. Now, the first thing I actually want to sketch is the function y equals x minus 2. Now, I'm doing this in grey on here because I don't want it to be a feature of our graph, but it is going to help me. So y equals x minus 2 is going to be a straight line going through minus 2 and 2. And it's going to be a straight line going through there. Now, having that sketched is going to help me figure out what my reciprocal function is going to look like. Okay, so if we have a look at this, wherever we have 0, so our original function has a 0, that's going to be a vertical asymptote because we can't divide by 0. So that's going to help us with our first bit. We can draw that in there. X equals 2 is a vertical asymptote. And now we can have a look at either section of that graph. A look at the right-hand side here. We know that it's always positive. It's always above the x-axis. So our reciprocal will always be above that x-axis as well. And over to the left-hand side of that asymptote, it's always negative. So our reciprocal function that we're trying to sketch will be below that x-axis as well. Now, if we have a look over here, we know that as we divide by a large number, so this one's going off towards infinity, as we divide by a large number, it's going to give us a very small number. So we're going to come down here towards 0. The other thing we said is that as y goes to infinity, as x goes to infinity, then in our reciprocal function, the x-axis is going to be a horizontal asymptote. So we know it's going to come down here. As our original function gets bigger and bigger, and we're dividing by it, we're going to get smaller and smaller and smaller results, closer and closer to 0. So it's going to come down towards that axis. And as we use smaller numbers to get closer and closer to 0, we're going to get very, very large answers. So what's actually going to happen is our graph is going to curve down like this. Okay. Now, on the other side, it's going to be similar. As we get larger and larger negative numbers, we're going to get, in our reciprocal, values closer and closer to 0. And as we divide by numbers closer to 0, we're going to get larger and larger numbers. So it's actually going to curve the other direction. Is just a sketch, so it's not to scale. But one of the other things that we can consider that might help us graph is that whenever our original function, this one here, had a y value of 1 or minus 1, then the reciprocal function is going to be the same. So wherever this graph had a y value of 1, so that might be this point here, then our reciprocal function is going to have a y value of 1 as well. Over this one's the one that's not very to scale. At minus 1, they should have intersected more at minus 1, so probably should have intersected more like here. But because it's a sketch, it doesn't have to be to scale. The thing just to consider is that our original function y equals x minus 2 was always increasing, and the reciprocal function that we have is always decreasing in its two sections. So we're just using that as a double check. All right, so that's graphing that reciprocal function. Example asks us to sketch the reciprocal of this function shown here. So the first thing, the easiest I think to start with, is that wherever there are zeros on our original graph, there are going to be vertical asymptotes. So we can draw one vertical asymptote going down here on that y-axis. And we can draw another one here through 4. So that's going to split our reciprocal function into 3 sections that we can have a look at. Over on the extreme sections, over to the sides, we know that our reciprocal function is always going to be positive because our original is, and in between the asymptotes, our reciprocal function is always going to be negative. Now, because this function goes off towards infinity, as x gets larger, so does y, that means we know that the x-axis is going to be an asymptote, and because it's getting closer to 0 here, it's going to go up towards infinity near this asymptote. So it's going to curve down, very similar to what happened in our last example. And the same thing is going to happen over this side as well. Then we need to have a look at what's happening in the middle. So because we're getting closer and closer and closer to 0 from the negative side here, that means as we get closer to this asymptote, our reciprocal function is going to head towards negative infinity. And the same thing as we head over to this side, because we're getting closer to 0, we're dividing by smaller and smaller numbers. Our reciprocal function is going to get larger and larger in the negative direction. We have a minimum here at x equals 2, which means that in our reciprocal function, we're actually going to have a maximum. We know, like we said before, that our function is always going to stay negative, so I'm going to put my maximum here. It's not going to go above the axis. I don't know exactly where it's going to sit, but that's okay because it's just a sketch. So we're going to end up with a curve like an upside down parabola here. Right, that bit's not very neat. It should have been a little bit neater than that, but that's what our reciprocal function is going to look like for that one.